All right, so in this video, we're going to be looking at two examples that involve cost, revenue, and profit. So in our first example, a school is selling candy bars for $2 each to raise money for their sports teams. The cost to the school is 85 cents per candy bar, and they have an overhead of $175. Now, the cost function is just going to be a linear equation that depends on the cost per candy bar plus the overhead. And the revenue equation is simply going to be the cost or the revenue taken in per candy bar. So the question then asks, how many candy bars do they need to sell to break even? Now, typically, these problems are solved as if they were equations. So we think of the break-even point as when the revenue equals the cost. But technically, it's the first sold item when the cost is just barely less than the revenue, or it can be equal to. But in real world situations, you're rarely going to get exactly a whole number of value of items sold to get to the break-even point. And so this inequality is actually going to dictate how we round when we get an answer that is not a whole number. Now, I'll go ahead and I'll solve it as though it's an equation because that's just easier to work with. But kind of keep in mind, this is really in the background. It's when the revenue equals or just barely exceeds the cost. That's the actual break-even point. All right, so let's solve this. So we've got 2x is equal to 0.85x plus 175. We're going to move the x over to the other side, and we're going to end up with 1.15x is equal to 175. And then we're going to divide 175 by 1.15 and see what we get. And we get, and I'm going to put an approximately here, 152.173 blah, blah, blah. Now, again, the thing to keep in mind here is you can't sell fractions of a candy bar. When you sell a candy bar, you sell a whole candy bar all wrapped up and ready to go. You do not sell a part of a candy bar. Now, when we get to rounding, we might normally think, oh, we should round to the nearest whole value. But the problem here is that if I round down, then my cost is not going to equal or exceed my revenue. So let's just double check. If I put in 152, I'm going to get 0.85 times 152 plus 175. That's going to give me 304. 304.20. And what about my revenue at 152? Well, it's going to be 2 times 152, which is 304. Again, notice that at this moment, I have not yet broken even. If I sell 152 candy bars, I am still technically losing money. I'm actually losing only 20 cents, but that is not the break-even point. I have not made back all of my costs yet. Therefore, you need to round up. Regardless of what the decimal is, you need to round up because that is the first point where you are going to have enough revenue to cover your cost. So 0.85 times 153 plus 175 is going to be 305.05, and the revenue at 153 is 2 times 153 is 306. And again, this is the first point you've made a profit. That is the break-even point. So that's where that inequality matters. Always, 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 when you're doing these problems, if you do not get a whole number, you must round up. Now, we can get a similar kind of problem that behaves a little differently if we have an equation for the price. Now, the price, recall that our revenue function is the quantity times the price. Now, if we have an expression for the price that is a constant, as in the previous example, this just becomes, as we saw, 2x, for example, since we're selling them for $2. But if the price is variable, it depends on demand and supply and those other kinds of things, then we will sell different numbers of items depending on the actual price that we set. And in that case, we get a revenue equation that is not a linear equation, as we saw in the previous example. The cost usually does not change. But if it is not linear, they will usually give it to you. So here, our cost, we're spending $40 to build every new widget, and we have an overhead of $5,000. So that's our fixed cost. The revenue is X times P, but P is 200 minus X, which gives us 200X minus X squared. So essentially what this is saying is that if I make the price $200, I'm going to sell nothing. But if I make it less than that, I will sell more. And so then the question becomes, what do I have to sell this for in order to make a profit? And when can I make the maximum largest possible profit? So the profit is just the difference between the cost and the revenue, with the revenue going first. So our P of X, capital P of X, is going to be 200X minus X squared minus 40X minus 5,000. The key thing to keep in mind in this example is that, sorry, this was a plus. You need to make sure that you distribute, I'm getting ahead of myself, distribute the negative from subtracting the cost, or your equation will be incorrect. And if we combine like terms, negative X squared, 200 minus 40 is 160, X minus 5,000. Now, this is in this kind of an example, a quadratic equation. So how do I achieve the maximum profit? Well, I need to, on a parabola that opens downward, I need the vertex. So recall that the coordinate of our vertex is negative b over 2a. This is why I've put this in descending order, so that we know that b is 160 and a is negative 1, which is going to give me 80. So I need to sell 80 items. That's the X is the number of things sold. And therefore, the price, to achieve that, I'm going to put that into my little p of X. 200 minus 80 is going to give me 120. So I will make the most profit if I sell 80 items at a cost of $120. And I can then put this into the profit equation to find the maximum profit. Again, put in the 80, not the 120, because our profit equation is based on the number of items sold, not the price. X is the number. And what I get when I plug that in is $1,400 of pure profit. given that, it's probably a good idea that they find a way to reduce their fixed costs. But this is how we go ahead and we solve cost, revenue, and profit equations. I could also, for this, find the break-even point. This would be the first point at which, again, the profit exceeds zero. So break-even can also be represented as the first point at which the profit is greater than or equal to zero. And so for this particular problem, we would want to know essentially where the zeros of this were, and then we would choose the smaller value because that's the first number sold where you make a profit. So we could go ahead and we could solve that. Here's our quadratic formula. And if we plug in our values, we've seen our -1, we've seen our 160. This would be our 160 squared. And then this would be our -1 and -5,000. 160 squared minus 4 times 5,000. Because I have 3 negatives, it is a subtraction. So I end up with 5,600 under the square root. And so we're going to end up with -160 plus or minus the square root of 5,600 all over -2. And just to make this a little easier to simplify, I'm going to simplify my radical just a little bit. Probably not all the way, but I don't really need it all the way. I know that since there's 2 zeros there, there is a factor of 100 that I can take out of 5,600. The square root of 100 is 10. Divided by -2. That's going to allow me to simplify my denominator with my numerator. -160 divided by -2 is 80. And then plus or minus 5 square root of 56, which is still under there. Again, I could simplify this more, but I don't really need to because I'm going to put this in the calculator. Now, the 80 plus 5 squared of 56, that's the upper value. That's the maximum number I can sell and still make a profit. I want the smaller value. So 80 minus 5 divided by the square root of 56 is the smaller value. I have to sell approximately 42.5834 items in order to achieve a profit. But that's, again, that's the equality. That's not the, that's, again, I can't round down, even regardless of what the decimal place is. I can't sell 42. I need to sell at least 43 items to make a profit. Again, because I have to have a whole number of sales, whole number of items sold, and if I round down, I will always fall short of that break-even point. I will make not just quite enough revenue to cover my costs. So I round up to the next whole value, and then that will guarantee that I will make a small, but nonetheless non-zero profit.